Have you ever seen one of these before? This is an actuator. And although many different kinds exist, we're going to be focused on what a proportional actuator does. And many refer to them as modulating actuators. You'll see these often in economizers, in cooling and reheat valves. But most importantly, in today's video, we're going to be focused on how an analog output plays into effect when it comes to an actuator. Okay, so one thing is to understand how an actuator works. Another is how to install one. So the first thing I do is find out in what direction do the dampers move. So I have a couple of things here. I have the duct, I have the shaft, and my dampers. So I'm gonna test it. I'm gonna go ahead and move it to the left or counterclockwise to see if it opens, and it doesn't open. But as soon as I go to the right or clockwise, you can see it open. So okay, so as I go to the right or clockwise, the dampers open. So that kind of gives me an idea. Now I know how these dampers open going clockwise. So that's important to understand because on your actuator here you have this setting here. So by me having it with the arrow facing up, it's gonna drive it clockwise so it can open. You can also have it the other way, you see facing down, and it's gonna open counterclockwise. But in this case, I'm gonna start that way so that for me to open it, it's gonna drive it clockwise. And as you can see, by me holding the clutch, I can go to the right, left. But by me having it in this setting, it's gonna, as soon as it receives a signal, it's gonna open it clockwise along with this with these dampers. Okay, so I got the duct closer so you can see how I'm gonna install the actuator. So I have a couple of things. I got my actuator. I got this the base that it comes with. It kind of keeps the actuator in place, and it's nice the way these work because this part here, this lip, it's a lot bigger than that hole, but you're able to put it and feed it through the bottom. So the way that goes is right there. You see it going up. So even though you can go forward and back, the actuator does not come out. So we got to put the base along with the actuator. So what I like to do, I go ahead and press the clutch, right? Go to the left, put it in here. And now it is important that we screw in this base so that the actuator does not come out. And many of you use your drills a lot of the times using one hand because maybe your other hand's busy doing something else with maybe whatever it is you're working on the unit, on the controller. So I'm gonna try my best to screw this in with one hand here. So okay, that wasn't too bad. And so now I gotta get this other side. So as you can see, this came off, but I think I might be able to remedy it. There we go. Okay, go ahead and position it, and I'm gonna put the other screw on here, and of course it falls into the abyss. Those screws, when they fall, you can never find them. Thankfully I was able to find this one, so go ahead and screw that in. All right, so that's good. Now that actuator, see, I'm trying to pull it out, but it's not coming out, even though there's a little bit of movement, but it's not going anywhere. So now it is important that we tighten up these bolts right here. And then this part here is gonna grab on to the shaft. So let's see if we can get closer right there. So we gotta tighten these up. So what I do, I like to hand tighten them first, right? Righty-tighty. So let's go ahead and tighten that up first with our hands. And then I'm gonna get my socket wrench here and then tighten these up too now. Okay, yep. All right, so now we gotta test it. So I have my clutch, I got the shaft, I got my dampers. So now I'm gonna go ahead and press this clutch here and then see if I can, by me going to the right or clockwise, if it's gonna grab on to the shaft and open the dampers. So let's go ahead and go to the right. Nice. Tamper's completely open. And as you can see, I this was able to go all the way to my right. So it's working now. And let's say I want to close it now, because you always want to make sure that you're able to open it and close it completely. Now I'm going to push it and go to the left. Now it's closed. And now that's also in the closed position. So the installation went well. Now we can get into the wiring and the signal as well.
Okay, so this is a close review of the Balimo actuator, and there's four things down there: black, red, white, and orange. What do they mean? Let's find out.
Okay, so on the actuator, we have a couple of things to have in mind. Um, it's saying that it takes 24 volts, either alternating or direct current. We're specifically going to be giving it 24 volts AC. Now, the input or the signal, it's 2 to 10 volts DC. So this is important to understand. This is DC. Now, when you look at these four wires, and you actually do have four wires, at least in this specific actuator. Sometimes you'll just have three, but this one you do have an orange, a black, a red, and a white. So according to the actuator, it tells us information as to what these wires mean. Now, sometimes you would wish that it would be in English, meaning just tell me what takes 24 volts, tell me what takes 2 to 10 volts DC signal, and so on and so on. Just make it easy for me, but they don't a lot of the time. So, but these two here, this is my 24 volts AC. Black being my common or ground. This is my hot right here, my 24 volts. And this one here, it is my 2 to 10 volts DC going to the actuator. So this signal is coming from the actual controller. And it's interesting because they even draw it out for you in the actual actuator. They have a little triangle, but it's an actual arrow of it going to my wire to my actuator. And this orange wire is a feedback wire. This one is going from the actuator to my controller. So this is here an analog input. And a lot of the times they refer to it as your feedback wire. They use it a lot in economizers to make sure that whatever the actuator is actually doing is going to give you a true value. Just because we send a signal, it doesn't mean that it's actually opening. A rat could have chewed up the wire. I mean, a lot of things could have happened. But the one we're going to focus on today, and we can maybe do this feedback wire on another video. This one is um, when sending a signal to the actuator, what is it gonna do? How is it gonna open? So as mentioned, it is a 2 to 10 volts DC signal. At 2 volts DC, it is 0%. It is closed. At 6 volts DC, it is 50%. At 10 volts DC, it is at 100%. And it makes sense. Half of 2 and 10 is 6. This is not a 0 to 10 volts DC. It is a 2 to 10 volts DC. So now let's go ahead and send a signal to the controller so we can get it to open.
So here I have a jungle. I have all these wires just staring at me, and many times that's how it's gonna be out in the field. You have all these wires, you don't know what's going on, but we're gonna take it step by step. So, um, yep, that light bulb just turned on, which is interesting. I must have a program downloaded. Um, yeah, that's funny how that happened, but we're not working with that controller now. We're working with the other controller, and so the other controller also is same thing. It has its analog inputs, analog outputs, binary outputs, but right now we're focused on the analog output. So that smaller controller doesn't have that function. This one does. That's why we have to use this controller. So there's the actuator, and you recall we have four wires coming out of that. We have the common, the ground, the feedback, which is the orange one. The white one is my signal, and the red is my power. We're not gonna be worried about the feedback today, but you see, I have them going to a wire connector. So then those wires then are coming out and going to my controller. So I have to confirm that those wires are correctly installed in the right place. I can have a good installation, but it doesn't matter if they're not wired correctly. So focusing on the red wire, which is my hot, my 24 volts. If you see there, it goes to that terminal block, and I have two small jumpers. Basically, it's just a path. And then on that bottom one, if you now follow it to the left, it is going to a purple wire. And so where is that purple wire going to? Well, if you were to follow that, it goes to 24 volts AC, it goes to power, but we still have to confirm it's actually getting 24 volts. So behind that, I have a white wire. And where is that white wire coming from? That's the one that's important. We need to make sure that it is 24 volts and it is going to my transformer, the source of 24 volts. It is on the hot on the 24 volts. So yes, um, as we can see, that red wire is receiving 24 volts. I have that purple wire going there. Then I have it coming out on the other side, two jumpers, and boom, red wire is getting 24 volts. So we're good with that. And now let's go ahead and confirm with the ground, the common. So I have it there going to number 12. So let's go ahead and confirm. And yeah, you have a lot of wires just staring back at you. But like I said, you just kind of uh, you can go ahead and pull that wire just to confirm you're working on that wire. And it's going to number two. And number two, as you can see, it says ground. So it is going to my common, it is going to my ground. My controller is receiving 24 volts. And we're going to focus on one more, our last one. That white wire, which is my signal, my 2 to 10 volts DC, is coming in here as a blue wire. And then that blue wire now goes to number 11, coming out as a purple. And that purple one is now going to that block. And if you follow it, it says number one. It's going to number one, and it says analog output one. And I put it on number one. That is my 0 to 10 volts DC. And I have it already set as a 0 to 10. I didn't put it on the milliamps, 20 milliamps is already set to 0 to 10 volts DC. So yes, all my wiring is correct. Like I said, you can have a perfect installation, but if the wiring is not correct, it will not work.
Okay, so I've opened up my software and I already have a couple programs downloaded. The one we're going to be focused on is Control. And take a look at the logic. The logic is very simple. This is a parameter that can be changed by me, and this is my analog output. Now, this parameter, this is the percentage of the actuator of how much I want it open. So right now is at 0%. So it is a 2 volts DC signal. If I want it at 50%, the controller is then gonna be sending out a 6 volts DC. If I want it at 100% open, the controller is gonna be sending out a 10 volts DC to the actuator, which we're gonna test in a bit. But if you recall in some previous programs, we have to first tell it where to send that signal out. So I put it on analog output 1, not on 3, not on 5. I put it on 1. So I already have that ready. And this specific program here, it allows me to choose other settings. So we know it is an electrical signal or DC signal from 0 to 10 volts DC. And this one here is important. The actuator told me that it takes 2 to 10 volts DC, not 0 to 10. That is why I cannot leave it on linear full range. It has to be with this linear with offset 2 to 10 volts DC. Now, I still want to be able to scale it or want to range from 0 to 100%. So that is why at 2 volts DC, I it's going to be at 0%. At 10 volts DC, that's going to be 100% open. So now let's go ahead and get both screens here. We're going to get the software and the actuator with the meter so you can see what's going on. Okay, so here we have both screens, so you can see what's going on. Um, so right now, obviously the dampers are closed; it's not open. So what I was able to do, I was able to nick the wires so that you can see the volts DC. That once it receives, it will open according. So what I did want to just confirm is that we have 24 volts AC coming in. So let's go ahead and check that out. And we have 24 volts AC. Let me do it this way so you can see. So 24 volts AC. Good. So now I'm going to go ahead and switch it to DC. So right now, because it is it is closed and I can see it, right? You can see it's 0%. It's not open at all. So I'm supposed to be reading 2 volts DC, right? So because at 2 volts DC, it is it's not open at all. That is like the start. It's just closed completely. So I'm gonna go ahead and confirm, and I'm also gonna check common, right? Common, it doesn't change. But instead of checking the hot, I'm gonna check the signal. If you look at this white wire, this white wire goes to my blue, and this blue is going all the way to the controller on the analog output 1. I'm going to go ahead and confirm, and I have 2 volts DC. You can see right there to your right. So let's go ahead and send a 50% signal. So what is that going to give me? That's going to give me a 6 volts DC, and that's going to open the damper halfway. So I'm going to check common, and my signal, and I am reading, get this right here, 6 volts DC. You can see it right there, 6.1, 6 volts DC. So as I had mentioned, just because it's sending a signal, that damper can still not open just because it was installed incorrectly. But we confirmed that it was installed correctly. So, and you can see right behind the meter, the damper is actually opening. I can put my hand through. And so with these, you just have to wait. You can't rush the process. But now it is 50% open. I can put my hand through. But let's try 100% open. So what would the my volts DC be? It's gonna be 10. So let's go ahead and send that signal. I want it 100% open. The controller is gonna be. You want it 100? Okay, let me think. I'm at 2 to 10 volts DC. 10 volts DC is at 100. So let me go ahead and send a 10 volts DC. And that is what's going on. And then as we check and confirm, we're getting 10 volts or 10.1. There we go. Let me just confirm. $10 volts or 10.1 volts DC. And my damper is completely open. I can put my hand through. So it's working, right? The volts DC is working in such a way that it's opening the damper accordingly.
So I was able to go to a package unit with an economizer, and right off the bat, you can see a couple of things that you already recognize. I have my damper back there. I have the actuator. This is a Honeywell actuator, and the shaft along with that wheel that gets the damper moving. I have my Honeywell Jade controller where the 2 to 10 volt signal come out from, and then that thermistor there. And taking a closer look of that actuator, yeah, it has a shaft. It moves that wheel so it can then move that damper. And if you look at the actual wires going to it, there's only three. We already know that that red is my hot, my 24 volts. The black one is my common, my ground, and that white one is my signal coming from the Jade, that Honeywell controller, that 2 to 10 volts DC signal, and there's also a feedback function on the bottom. But that actuator will work according to whatever signal it receives, but it first needs to be receiving 24 volts AC. So don't feel intimidated. Next time you go to an system with an economizer, now you know what to look for. This is not hard at all. You can definitely master this. Until next time.